What if I told you the deepest point on Earth, the Mariana Trench, could also hide its most extreme volcano? Imagine a geological giant, forged under pressures that would crush a submarine, spewing molten rock into the abyss. This isn't just a hypothetical thought, it's a fascinating scientific possibility we're diving into today. The Mariana Trench, located in the western Pacific Ocean, is the deepest part of our planet, reaching depths of over 36,000 feet. It's a place so remote, so hostile, that it feels like a world apart from the Earth's surface. But what if, hidden in the crushing darkness, there lies a volcanic force waiting to reveal itself? Could there be a volcano at the bottom of the ocean, so extreme and alien that it challenges everything we think we know about volcanism? Today, we are taking you on a journey to explore the Mariana Trench's potential as the home of a volcano that could alter our understanding of Earth's geology. From the crushing pressures of the ocean depths to the fierce heat of molten rock, let's uncover the truth about this unprecedented geological mystery. Imagine a mountain of fire, not on land, but at the very bottom of the ocean. Deeper than Mount Everest is high. This hypothetical volcano would be one of the most extreme geological features on Earth, hidden in the vast and inhospitable Mariana Trench. Today, we're diving into the Earth's most extreme environment to ask a simple question. Could there be a volcano in the Mariana Trench? The Mariana Trench is the deepest place on Earth, a dark and mysterious chasm located in the western Pacific. The trench stretches across over 1,500 miles, with its deepest point known as the Challenger Deep, plunging to about 36,000 feet. To put that into perspective, Mount Everest, the tallest mountain on Earth, stands at around 29,032 feet, meaning the Mariana Trench is deeper than Everest is tall. This makes the trench a hostile environment. The pressure at the bottom is over 1,000 times greater than at sea level, and temperatures hover just above freezing. The trench is a crushingly dark, cold abyss, a place where no light penetrates, and the conditions seem hostile to life as we know it. Yet despite these extreme factors, the trench has been found to harbor unique ecosystems. Remarkably, life does exist here, adapted to the extreme conditions. But how could a volcano survive in such a brutal environment? The central mystery we're exploring today is this. How could something as hot as molten lava exist in such a cold and pressurized environment? It defies intuition, yet there are compelling geological forces at work beneath the ocean floor that might suggest that volcanic activity could exist at these depths. But before we dive deeper into the possibility, let's examine the conditions that make the Mariana Trench such an extreme and unique location. To comprehend why a volcano in the Mariana Trench would be such an anomaly, it's important to understand the basic geology of the trench itself. The Mariana Trench was formed by the process of subduction, where one tectonic plate is forced under another. In this case, the Pacific plate is being subducted beneath the smaller Mariana plate, causing the ocean floor to plunge deep into the Earth's mantle. This tectonic activity creates a dynamic environment where magma from the mantle could theoretically rise to form volcanic structures. However, there is a problem. Subduction zones usually occur at plate boundaries where volcanic activity can be more easily observed above the surface. The Mariana Trench's depths, though, would make it a much more challenging place for volcanic activity to manifest in a traditional sense. Yet, as we have seen with other extreme environments, nature has a way of defying expectations. We know that deep-sea hydrothermal vents exist in the trench, places where superheated water is expelled from the Earth's crust, creating unique ecosystems far from sunlight. This gives us a clue that beneath the trench there could be significant geological forces at work, forces that could potentially create volcanic activity. The Mariana Trench is not a singular geological feature. It is part of the larger Pacific Ring of Fire, a vast area of intense seismic and volcanic activity that encircles the Pacific Ocean. The Ring of Fire is home to some of the world's most active volcanoes. and the trench itself may be a critical component of the forces driving volcanic activity in the region. Now let's consider the science of submarine volcanism. Submarine volcanoes are underwater volcanic vents that can range from small fissures to massive seamounts, underwater mountains. Some of these volcanoes are massive, and many are part of the oceanic ridges where tectonic plates are constantly moving apart. The heat and pressure from the Earth's mantle force molten rock to rise, but instead of bursting through the surface like land-based volcanoes, the lava slowly builds up and solidifies under the ocean, creating vast underwater mountain ranges. In the context of the Mariana Trench, the pressures and conditions may be extreme, but that doesn't rule out the possibility of volcanic activity. In fact, volcanic eruptions do occur in some of the most extreme environments on Earth. In other parts of the Pacific Ocean, submarine volcanoes have been found near the Marianas, such as those near the Challenger Deep. Some of these underwater volcanoes are not just dormant but active, occasionally releasing plumes of smoke, gas, and even lava. The idea of a volcano at the very bottom of the Mariana Trench, though, is more extreme. The depth of the trench, combined with the intense pressure, makes it seem unlikely. But volcanic processes rely solely on temperature and pressure. They are also driven by tectonic forces and the movement of magma beneath the Earth's crust. The subduction occurring beneath the trench could create conditions conducive to volcanic activity, even at the deepest points. The question remains: how could molten rock exist at the bottom of the Mariana Trench, where pressures are so high and temperatures so low? To answer this, we need to look at the unique nature of volcanic processes beneath the ocean. At extreme depths, the pressure is so great that water cannot boil at normal temperatures. This means that even though the temperatures within the Earth's mantle may be hot enough to melt rock, the molten rock would stay in a more stable, semi-solid state due to the intense pressure. However, the heat generated by tectonic activity and magma movement can still force volcanic eruptions to occur, albeit in a very different manner from what we see on land. In addition, volcanic eruptions beneath the ocean can happen without the large explosive events seen on land. Submarine volcanoes often produce what's known as effusive eruptions, where magma slowly oozes out onto the ocean floor rather than erupting violently. These eruptions can create new seafloor, just as land-based volcanoes create new landscapes. A volcano at the Mariana Trench would have to be a different kind of geological anomaly, one that thrives under extreme pressure. The heat and pressure deep within the trench might cause magma to behave differently, leading to volcanic activity in ways we are only beginning to understand. Could it be possible that an active volcano exists at the deepest point, one that erupts quietly into the abyss, creating a new landscape beneath the ocean? One of the most intriguing aspects of underwater volcanic activity is the potential for unique ecosystems to form around it. Deep-sea hydrothermal vents are known to support rich ecosystems that exist entirely without sunlight. These vents, where superheated water and gases are expelled from the ocean floor, provide an environment for organisms that thrive in extreme conditions. If a volcano were to exist at the bottom of the Mariana Trench, it could create an entirely new ecosystem. The heat and chemicals released by the eruption would support life forms adapted to the extreme conditions, much like those found around other underwater volcanoes. These organisms would rely on chemosynthesis rather than photosynthesis, drawing energy from the chemical-rich environment rather than from sunlight. The organisms around hydrothermal vents include giant tube worms, shrimp, and bacteria that form the foundation of these ecosystems. The potential for similar life forms to exist near a deep-sea volcano in the Mariana Trench is both fascinating and unexplored. Just as the hydrothermal vents on the ocean floor support a vibrant and unique ecosystem, a volcano at the trench's deepest point could also provide a similar haven for life. The idea of a volcano in the Mariana Trench is not just a theoretical concept, it's an area of scientific interest. Although no such volcano has been definitively discovered, the search for evidence continues. Advanced oceanographic techniques, including remotely operated vehicles, ROVs, submersibles, and deep-sea sonar, are making it possible to study the deepest regions of the ocean floor more closely than ever before. Scientists are keenly aware that the Mariana Trench, being such a dynamic geological feature, could be hiding more secrets beneath its surface. There have been numerous expeditions to explore the trench, and each one uncovers new and surprising aspects of its geology. While no clear evidence of an active volcano has been found, the search continues, as does the study of the surrounding geological features. With advances in technology and an increasing focus on ocean exploration, it is only a matter of time before we learn more about the trench's deepest regions and whether or not a volcano lies hidden beneath the abyss. As we conclude our exploration into the possibility of a volcano at the deepest point on Earth, one thing is clear. The Mariana Trench remains one of the most mysterious and extreme places on our planet. Whether or not a volcano exists at its deepest point remains an open question, but the scientific intrigue surrounding this possibility is undeniable. The trench's extreme conditions, high pressure, cold temperatures, and isolation make it a challenging environment for volcanic activity. Yet the forces at work in the Earth's mantle, combined with the dynamic tectonic processes of the region, suggest that the trench could indeed harbor some of the most unique and extreme volcanic phenomena on Earth. As we continue to explore the depths of the Mariana Trench, there's a good chance we'll uncover even more astonishing secrets hidden beneath the waves. Whether it's a volcano or some other geological anomaly, the trench reminds us of the vast and untapped mysteries that lie beneath our oceans, waiting to be discovered.